Thank you. I'm delighted to be here. This is a place I've had the privilege of talking occasionally, and mostly have had the privilege of rooting, strongly against, having done my graduate work somewhat north and east of here in a small town north of Oakland. But we're not really rivals. We're trying to solve the same problem. And we don't want to update Adobe right now. As much as it sounds like a great idea. And we don't want to update Lenovo. You're not getting all these updates, but I am. And my best interpretation of this is that you have a friendly network that has suddenly brought my computer to life. I titled this talk, retitled it, as you saw the original title, The Experimentalist's Manifesto, because it gives me the liberty to go out and say a few provocative things and implore you to do a few things. And I'll sprinkle some research and other stuff in along the way. But it's really about a philosophy of research and a philosophy of ways of knowing things that I hope will prove entertaining and also informative. The truth is that's going to depend a lot on you. I welcome your questions, your input, even violent disagreements here and there, and feel free to bring those up even along the way. This isn't, I know that being recorded will run into the issue. I'll repeat questions so that the person who comes by and watches this, in 3 weeks can hear what you had to say, but don't be shy. Otherwise, I'll just keep talking, and that doesn't make anybody particularly happy, least of all me. So I'm going to start with a couple of We're going to start by making this thing come back. I'll start with a couple of disclaimers. Disclaimer number one, I like building stuff. And some of what I say is going to come from that perspective. But I'll tell you right up front that I'm going to make an argument that there's a certain amount of research that is really hard to do well if you aren't willing to build some stuff. And I'm going to bring this up because of points that are coming up later. Point number two, I enjoy the ability to inflict the things that I'm curious about on other people or experimenting on others. I try to do so ethically within the confines of my human subjects review committees and all of the applicable laws and even the non-laws. I occasionally ridicule the rules about human subjects research because how many people here have submitted something to an IRB even for just exemption? So some of you know this. For some of you who don't, anytime you conduct human subjects research at an institution receiving federal funds, of which this is one, you need to have that work reviewed by a review board, which in our field mostly looks and says, yeah, what you're doing falls under some weird exemption because it has no harm and it's sort of like a survey or something. If you're doing really risky stuff, like injecting people with drugs, which I know they do down the road, this makes a lot of sense. But the thing that's always struck me as strange is that the ethics rules all go away if you don't care about the results. Their definitions of human subjects research are that you are interacting with somebody or getting data about somebody in order to learn something generalizable about that person. And so my favorite example when I talk with IRBs about where this is a challenge is if I have a large cast iron skillet and I hit somebody over the head with it and observe the pain that is occurred, I need to get IRB approval if I'm going to try to publish about that. Strangely enough, if what I do is hand all of you a survey, or better yet, I just watch you to see if you laugh, and I hit him over the head, but I don't watch him, it's exempt because what I'm giving you is a survey, and I'm not studying him. And better yet, if I just think it's fun to hit people over the head, I don't need approval at all. I'm not suggesting we do this, but I am suggesting that this is a time that these rules are actually currently under revision, and there is talk about taking a lot of the work that we do that is exempt out of the jurisdiction of normal research review. And this might be a time to watch that if you're somebody who cares about this in the field. But the third disclaimer is probably the most important one. I've probably read too many research papers. In the course of a career, you hit this point eventually. And it gets worse when you are willing to review the papers along the way. And I've gotten grumpy about the fact that I see a lot of research that after I look at it, I realize it was flawlessly executed and has no practical significance whatsoever. And in many cases, it was flawlessly executed and has no practical significance in a way that makes it look as though somebody had the mission of saying, what's the least amount of work I can do to get this work out there and into the field, rather than saying, what's the question I really want to know the answer to? And this talk really goes in that direction of saying, how do we shift away from that? There we go. So you're going to see three things here. You're going to see an introduction. I stole this organization. There's a lot of people who put this up, and this is what your talk is supposed to be. That's followed by three substantive sections where we talk about deep things like the purpose of research and observation, analysis, and experimentation. And what I think may be the area where we have the most to contribute from our lab's experience about, when do you want to own your own infrastructure versus inhabit other people's infrastructure? When are the experiments you're going to carry out more effective in the lab versus in the field? And then I've been promised that I will be inspired to come up with a witty and insightful conclusion, and I hope that shows up by the time we get to the end. So this introduction that I talked about started with the fact that I'm sort of getting bored. You can find a tweet that suggests that 72% of tweets contained made-up facts like this one. That's not all that interesting, but you could probably find it on Wikipedia if you'd give me a minute. I've seen too many papers, and I will be honest, I've seen these papers not just from people who would say they don't know any better. I've seen these papers from my own students at times. I've seen these papers from colleagues I know do some fantastic work that are not exactly, but are not very much different from saying, well, 100% of users using our new whiz-bang desktop video conferencing system used the spacebar. You see these papers with charts of which command did each person use and which modality. Thanks. Why? Why did they use the spacebar? Is it possible that 100% of your users had thumbs? We don't know. We distributed the software over the internet. We didn't take pictures. And of course, there is theoretical work that's going on, but I don't always find that theory stuff that I'm able to apply. I refer to this as the meat slicer theory of collaborative systems, right? That users hang together until they're sliced apart, and then their inner strength determines if they stay whole or shred. You've probably never heard of this because I made that one up, but that's a theory. You could use it to guide things. It's completely true with the meat on a meat slicer, right? That you slice the turkey and it falls apart if it's not strong enough. It doesn't mean anything, though. There's no data behind it. There's no depth behind it. There's actually nothing behind it at all. And of course, this is the grumpy old guy part. It might not have been this way in the past. It felt to me like, as I was writing this talk the first time I started thinking about these issues, that part of what's happening to our field is that there's more data than there ever used to be. And because there's more data, there's this immense temptation to analyze it. When some of us were in the field at the somewhat earlier stages, I won't claim to have been there at the beginning, but there was a stage where nothing was there, so you had to build everything from scratch. And I don't think we should go back to that. Those were horrible days, but they did lead to a lot of experimentation. So what are we going to talk about here? I'm going to start with message number one. It's a quiz. We're going to do this incrementally. We'll see if we all get the answers together. Why do research? How many people think we do research because it pays so much better than fields like law, business, medicine, and sports? For those watching on TV, no hands went up. Because it helps attract women, men, or whoever it is that you're looking for. For those of you on TV, one hand went halfway up and will be left there for the rest of the talk. And if you want to meet that hand after, never mind. Number 3, to contribute to knowledge. Ooh, a lot of hands. And because there are opportunities we cannot yet seize and challenges we cannot yet surmount. I don't know what that means, but it really sounds good. I thought that was why we climb mountains that have never been climbed. But yeah, we do this because we want to do something new and we want to learn something from it. We all get that. So let's get a little narrower. I care about something very specific. I care about social and collaborative systems. And we know there are certain failings in these systems today. Many of them fail right out of the box. If you talk to somebody who builds social and collaborative systems as a researcher, and frankly, I think this is true if you talk to people who build them as entrepreneurs as well, what you find out is that many of them don't work. They don't work not because they crash. Some of them crash too. They don't work because there was something in the social design that failed. I will give you one of my own painful examples. We spent a bunch of time building a community question answering site. I think I now mostly know why it failed, but it is still the case that 3/4 of the questions and answers in the site were posted by people that I either employed or paid in the course of experiments to post content. It was a great site, except for one critical thing, which is that the social environment it was designed for, by the time it was delivered, the social environment had changed. And it was delivered to match an environment that wasn't there anymore. And so people didn't use it. You could talk about social, software engineering problems. That was certainly part of the problem. But it was also a matter of we weren't fast enough to react. And when we realized things were changing, we were too slow to change with them. It's not just my site. If you go to the wiki world, and you go beyond Wikipedia to all of the Wikia projects and sites that are out there, most of them lack activity. This isn't new. You can go back to results from 15 years ago that said most discussion groups have no activity. And even those who have activity don't always have productive activity. Social systems built with the same template that was used for the last one that was good often fail because we don't know how to adapt them to the circumstances that are involved. And perhaps most important, we often don't know how to get them going. Many of these systems would succeed if only they were successful already. And that's not a very good recipe, unfortunately. If you were to put this as sort of a mission statement, part of what I want to do in life is make these systems easier to build well, and that means moving along a path that at one end is gambling. Gambling is, why don't you give us $250,000 and we'll get a system up and running, and if it works, we'll get rich. And we'd like to move from gambling to art, which is where some of this is now, to design, all the way out to engineering, where I'm defining engineering, just so that we have a definition that works for this, as a well-understood set of principles and processes and procedures that result in a predictably performing product as a result of the underlying science. The beautiful thing about engineering in the rest of the world is when somebody goes there and puts together a bridge, mostly, unless they're designing a bridge in circumstances that are outside the realm of what we've ever seen, the bridge just works. And this is true whether it's a bridge or whether it's a support beam in your house or whether it's a chip or other things, they just work. Yeah.
So a second ago you were talking about working in terms of working socially, and I'm slightly concerned whether you mean people use it, that working socially means there's evidence of use, because you can have a very functioning bridge that's built in the middle of nowhere that nobody uses, and we don't have any issue with saying that bridge doesn't work.
Agreed. So let me take what you said in two pieces of this. There's also work in traffic engineering that can give you much more predictable results as to whether people will use it, more predictable than we have in social computing today. I don't want to limit the definition of working to people will use it, but I want that to be a minimum, and I think it's that people will use it and it achieves its purpose. And, you know, Wikipedia would not be a success if it had, you know, 10 billion views a day and 500 million edits a day and everything in it were wrong. Propagandapedia might be a success under that goal, but none of us are really worried about that. So there's going to be some criteria for this that talk about success. And the key to this is some notion of engineering. And I'll just give you an example of the early work we started doing in this area. This is something we've been working on for a long time. This is a book, some of you may have seen it, edited by Bob Kraut and Paul Resnick, called Building Successful Online Communities, Evidence-Based Social Design. It probably should have said 1 at the end, because it's not complete. But it collected together a set of work done over mostly a span of about 7 years, and the predecessor work that had not been aggregated with it, to say there are certain things we know about how people respond to incentives, how people respond to certain kinds of social cues, social pressures. There are, unfortunately, this book is still mostly closer to design than engineering, because in a lot of these, it comes back and it says, you know, we know this, we don't yet know how they interact. And how they interact can be very important. Yeah.
My reading on this book and the broader literature, though, is like it's not necessarily about people will use this, because it sort of assumes in much of this literature that people are already there, that they have a need that this community is solving. But I feel like what you're getting at is something maybe different, which is that would they come at all? Is there some need that's being filled? And I wonder if these should be separated or not.
So there's a chapter in here specifically about the startup of new communities and is there a need and what's the niche and all of that stuff. A lot of this is how to manage an ongoing community too. It's much easier to do research on ongoing communities in some ways. But I think that from the perspective of who's doing the research, often it is separate. The whether there's a need kind of thing, often it's not us. This is the business schools that are addressing some of these issues. Other people are. What the techniques are, I think, is what we in the social computing field mostly work on, but they have to work together. And why do they have to work together?
No, why should we not be
understanding? I'm not saying we shouldn't understand it. I'm saying we shouldn't claim that we're going to be the only ones. I think we have to work with the people. No. No, but we have to do, it's often a case where we don't have the information to take the lead, but when we do, we should. In many cases, there have been people working on specific areas of market need and other things for long periods of time. Let's partner with those people and get the advantage of what they started with when we're going forward.
So if I can maybe try to get this, I'm trying to work this down to something that is easier for me to grasp a little bit.
Yeah.
Let's take like Cyclopath as an example.
Yeah.
It came out of their group. I feel like a major contribution that Reed made there was the notion that, you know, this online community could come together around a sort of different type of activity that they might have done previously. And I feel like that is, in some sense, a design and an engineering contribution but it sounds to me the way you're describing it, that would come out of a marketing program, not out of Reed or a CS research agenda.
Well, I think if you actually look at where it came out of a combination of Reed's CS research agenda. For people not familiar, Cyclopath is the term that's been coined for it, a computational GeoWiki. Reed Pridorsky, PhD graduate of our program, Lauren Terveen, designed and developed this system where you have a large map of an area designed to be edited into bike maps that are computationally usable to create routes. That's the fundamentals of Cyclopath. If you go to cyclopath.org, you can see the map. And when you see the map, what you'll see is any person looking at the map, like a wiki, can edit it if they find out there's something missing or wrong in the map. So they can edit it directly and say, wait a minute, these two streets, they connect, and on the map they're not shown as connecting. I'll make the connection. They can edit it by annotation and say, you know, this street is closed for construction through the end of March. Or they can edit it by annotating it in a computationally useful way that is subjective, like saying this street is a pretty street to bike on that people can query around. They can talk about things like it's bumpy, it's high traffic, and then somebody else can come in and say, I'd like a route from here to here, and specify preferences over the user attributes that are there and get routes and choices of routes and provide feedback. It's a very interesting system. And one of the great accomplishments of that system was the ability to get a bunch of people going and using it. The reason Reed was able to do that was that he was embedded within the Twin Cities active biking community. And in cases where you've got somebody embedded in a community, now this was not a case where the community came to him and said, here's what we need. He had an idea, but he iterated that idea through discussions with people in the community, and he put a lot of effort into getting some key people in that community to buy into this idea so that it could get up to the point where it had some level of critical mass. Was there anything wrong with him doing that? Of course not. It was a wonderful success. Not every person doing research in social computing will necessarily have had the length of investment into a community that they're going to be able to do that. But when you're capable of that, when you can embed yourself into a group that has a need, that's a fantastic way to go about doing things.
So can we separate out the contribution of the modes, the ways in which people were contributing to this wiki, I think that is what you're saying, from the establishment and existence of a need that brought people to that mode of collaboration. So like over here, the hanging out with the bikers can be a marketing thing, but this notion of creating a geo-wiki, for example, is more of a design or an engineering contribution in your mind?
I wouldn't say it that way.
Okay.
I would say that in order to do the design and engineering, you have to understand the community at this stage. Where that understanding happens will be different in different projects. In the industry world, you know, there's this dream notion that, well, the user experience person covers everything. In most companies that are not quite as enlightened today, it's still the case that the people talking to the end clients are more likely to be marketing and market research than they are to be technical people who will understand that, and you've got to work in partnership. In an academic setting, so some of the work that I've done with people developing communities for, one of them specifically was people on HIV drug cocktails, another one was for transgender individuals. In both of those communities, I couldn't get the depth of contact that I would have needed to deal with that community effectively in the design of a social system. I had partners that had, in one case, 10 years of experience with these people, in one case, about 7 years of experience. And the right thing was to get that piece of the puzzle from those partners. Now, those partners were researchers. They were health researchers. They weren't computer scientists. They didn't understand anything about the mechanisms, but they sure understood the issues of the community to understand where is identity important, where is anonymity important, what's the social relationships among the people in the community. And I think that depending on the project you're doing, those are the kinds of things that matter. Okay, so I'm going to give you a different example of a piece of work that we're now, roughly 12 years into. And it's, from some perspective, it's a highly mathematical piece of work. I'm not going to get you into all of the math, but it's fundamentally also a social computing piece of work. It's an area we call recommender engineering. So first quick thing, how many people are familiar with the term recommender systems? You'll notice I never ask you if you're unfamiliar because there's no reason to ask you to embarrass yourself, but there were hands that didn't go up, so I'm going to give a quick definition, not a lengthy one. Recommender systems are these personalization systems that typically operate on the basis of profiles of users' past preferences. The most common ones that I'm going to talk about are collaborative systems that use the preferences of a whole community and attempt to provide personalized feedback to each person. So you go to Amazon, you get people who liked this, liked that. That's a non-personalized version or ephemerally personalized. It's personalized to what you're looking at, but not to who you are. If you go to Amazon or one of 1,000 other places and they say, hey, based on your past stuff, here's what you think you should go buy today, that's personalized. These systems have been around now. The first published versions, the first published systems are just over 20 years old. The group lens paper in 1994, there was at the same time the, in early 95, papers on the Belcore video recommender and the Ringo system out of MIT. And we can argue forever about who was first, but you can look at the dates and what you figure out was the idea was ripe that 3 different groups came up with nearly the computationally same approach, and each submitted it for publication before the first one got published. You know, did somebody copy anybody else's work? No, the idea was just ready. And the idea at the time was, let's share somebody's ratings with everybody else and automatically use computation to find the people most like me to give the highest weight to when we figure out what I'm going to like. So if I think about a movie that I want to see, the first thing I do is I might go through the movies I've seen. I say, I liked such and such, who liked that, who liked this, who disliked this. And I look at all your hands and I pick a set of you that look like you have my movie tastes and I see what you folks like. We can make it more complicated than that. We don't have to. The technology is old. If you really want to learn how these systems work, you can figure that out in 100 hours in an online MOOC on recommender systems. You can see all the lectures for free. Well, me and Mike Ekstrand, who did a wonderful job, and we'll, you know, that's all out there on Coursera if you want to go find it. Very quickly, the shape of the field changed. The first paper published was a systems architecture paper. If you look at it, it basically said, hey, look, we've got this computational technique, and it turns out we can tag the data or have the data ride along almost for free with the content from place to place so that the data can be where we need to compute it. If you look at this, this was in an era where people were not yet used to real-time fast connections. The work was started in '92. And that paper, remarkably highly cited, mostly addresses issues no one would have cared about today. Because nobody was worried about, can I make my ratings go along in Usenet news groups that might get copied at midnight when somebody makes a long distance call. It's just not that big a deal anymore. The other papers spent a lot focusing on delivery, and they basically focused on the same basic issue. It works. It's innovative. And what it meant by it works was done differently in the different papers from '94 to roughly '97. But it works meant the thing that we predict for you that you will like, on average, you like better than the things we say you don't like. And there was a little bit of human centricity in one of the '97 papers that said, by the way, when we deployed this with, in the case of Group Lens, we went out to about 200 people over the internet. We gave them newsreaders that would use our server to go do this. And what we found out was when we displayed that something was good, they were more likely to read it than when we displayed it was bad. It doesn't actually check whether we were right, but we also had data that they kept using the system and other things. And you put it all together, and that was pretty good. The field shifted then. Over a period of years, the first next shift was, that's all really cool, but it's not efficient. Why is it not efficient? Because sure, it works fine when you have 1,000 by 50 or 10,000 by 6,000, but when you start having millions by tens of millions, like Amazon, for instance, needed, you can't compute these things fast enough. All the early systems were computing it pretty close to real time. Sometimes they'd have some pre-computed values. Well, suddenly out came a whole bunch of papers, and along later, when the patent office got there, patents too, usually not from the same people, saying, wait, we've got better ways to compute something that's close enough to as good to be useful. And the field changed for a moment, because in order to measure close enough to as good efficiently, the field needed a metric. And the metric that most people used was error. There's different measures of error: mean absolute error, mean squared error, root mean squared error. All of them are measures that say, if I predict something is 5 stars on a 5-star scale and you say it's 4 stars, I'm off by 1. If you say it's 3 stars, I'm off by 2. And so people started developing more efficient algorithms using many different techniques. Relating items rather than people was one of them that has been very successful. Matrix factorization techniques that are basically singular value decomposition and approximations to it. If you're not familiar with the concept, basically it's matrix compression. How do you reduce the rank of a matrix with minimum loss? And the rest you can go take linear algebra and come back for. But people took these techniques and they said, wow, this stuff is about as good. Sometimes it was even better numerically. And we had a running system at that point, a system called Movie Lens that we launched in 1997. The Movie Lens system was an accident. And I say this advisedly. What I mean by it was an accident is that we had no intention of writing a movie system, a movie recommender system. We had been doing Usenet news recommendations, and we knew that was going to die. It was way too hard to keep the software updated for a small number of users. But we were busy launching a company, turning this into products. And the folks actually not far from down the street at what was then the DEC Systems Research Center in Palo Alto had run their own movie system. They ran a system called Each Movie, and their research management people said, you've gotten all the research you need out of this system, shut it down. They hated the idea of just shutting it down alone. They had collected 2.7 million ratings from a whole bunch of users. They went out to the research community and said, does anybody want to take this and do something with it? We looked around and we said, we've got the tools, let's do it. And we actually got a master's student who replicated Each Movie in a month. I've never had somebody program a system as quickly since. It was an amazing effort. Got it up and running. At which time DEC's lawyers told us that we couldn't actually keep or contact the users, but we could use the data. And so we had to recruit new users on our own. The folks at DEC helped by mailing the users themselves and saying, if you're sad our system is shutting down, come to this one. It didn't hurt that we got some really nice publicity at the time. We got a couple of pieces that really helped make this happen. There were 3 of them that were notable in the history of the system. This is partly it was good timing, it was partly good luck, and it was partly the fact that the company that we founded at the time was paying $25,000 a month for PR. And there, you can't replace that kind of expense. And the 3-piece things that got Movie Lens to succeed were, 1, a very nice piece in The New Yorker by Malcolm Gladwell called The Science of the Sleeper. 2, a piece that was done on ABC News Nightline where they came in and they were talking about the commercial side, but they filmed our system to illustrate and show how it happened. And 3, we got a positive mention on At the Movies with Siskel and Ebert when they were both alive and still doing the show. And we got a whole bunch of people. Well, I want to connect the story back together. And the story connects back together with the fact that something really weird happened when all these new algorithms that were mathematically, numerically measured to be as good as the other algorithms, when we tried to deploy them on our system, users complained. Why did users complain? It took us a while to figure it out, but there were different adjectives that different people gave. The system's not as bold. The recommendations aren't as interesting. The recommendations are too conservative. What did this mean? Well, we've been spending a lot of time trying to understand how do you go from a field that had a metric and we optimized for it to what do you do when somebody says, that's nice, it's not wrong, it's just not right. And this work on recommender engineering is an example of what came out of that. Sean McNee earned a PhD looking at the issues of what are the factors that might be characteristics of an algorithm that might match to a user's characteristics or task characteristics or domain characteristics. How do you think about things like boldness and serendipity and diversity? When do you want a recommender? And we had various people along the way doing projects. Kai Ziegler visited us from Germany and did a wonderful project inspired entirely by his frustration of going to Amazon and seeing recommendations for 7 or 10 books that were all basically the same. Now, if you liked Tolkien, there are lots and lots of editions of Tolkien out there. And if you like other things plus Tolkien, you sometimes still get all the Tolkien. And he was saying, how can you tell this system, I don't like that? You know, I also like travel. I also like these other things. Can you make them make sense for me? And the answer was, well, you can measure diversity. And if you measure diversity, you can tune for diversity. You can measure what's been called serendipity. Serendipity was one that first appeared in one of the patent applications and later got into the research literature as a measure of, is it unexpected? It's a weird thing to measure because in order to know that, you have to know what's expected. So you need a baseline that says, oh, when you're recommending movies to somebody who likes science fiction, everybody recommends this. If you recommend this, it will be expected. Well, should you recommend things that are serendipitous? That's a different challenge. Michael Ekstrand, who graduated just last, I just did that terribly. You used the grammar correctly, who was graduated. It's a terrible thing to misstate that, even if it's commonly done. Who was graduated with his PhD last summer, is now a faculty member at Texas State, built a suite of tools, including LensKit, which is a research recommender toolkit, freely available. If you Google LensKit, it will take you to it. And its whole purpose was to say, let's give people the tools where they can produce 8 or 12 or a dozen metrics or build a live system with an engine behind it to experiment on. And there's dozens of experiments that have been run, some by us, some by other people in the field, all of them trying to get to this sense of engineering of saying, how do people respond to different properties of a social algorithm? Now, I just gave you those examples for one of the least social of the social systems out there. When we started Movie Lens, nobody was talking about it as social computing yet. The term hadn't caught on. When we first started working with psychologists, the first 2 people we worked with outside of computing were Bob Kraut and Sarah Kiesler. There's a lesson in that. There's a long story, but the lesson in that is if you're going to work with people in the field, try to get some of the top people because they have a lot of insight. And it was very interesting because at the first meeting we had Bob knew a lot about our system. Sarah didn't yet. She went, she used it, and she came back and she said, there's no community there. Of course, she was right. We'd been talking about online community, and the community was, I rate a movie, and in some invisible algorithm, people come out and use that data. It's community with a really small c and no immunity. But it was a start for those sorts of things. And since then, we've been building up more and more social features and continue to do that. But the essence of this is, doing this work took a lot of different approaches. There's mathematical, analytical work with data sets. We'll be honest, the thing that got Movie Lens the reputation it got in the research community is neither our brilliant interface design nor the community's need for another movie recommender system. It's the fact that we made the data public for other researchers, and we can point to roughly 3,000 publications that use that data set. I have mixed feelings about that because many of those publications can't get at what really goes on because all they have is the data set and they don't have the users. So let me pull this back to the point I was making. Generalizability and validity. If we're trying to build a theory that can support an engineering, we're trying to build science that is usable, there's two obvious questions, and my apologies, I'm sure you all learned this somewhere, in grade school. But if your computer science curriculum is very much like mine was, you never learned it again afterwards unless you took a course in the social or natural sciences. But you care about the question of internal and external validity. And internal validity is a measure of whether what you did right. Did you control for everything? In social computing, we have areas where we do this really well, and we have areas where we don't do this really well. But we can conduct controlled experiments where we do a nice job varying only one thing, except in the cases where doing that distorts the two populations. And obviously, if the populations are different, things change. We had an interesting story. We're working with a student on this one right now, where we have a really nice research question that we don't know how we can study. Because the really nice research question involves intervening with new users of our system before they start to use it. Except new users of our system are extremely fragile. When you put a login screen in, on some systems you lose 80% of the people. If you try to put in a survey before you get to do anything, who's left? Let's say you lose 70% of your people. Are those 30% like your control group? I guess you could do a control survey that's just as painful but has no actual content. But we're also worried that we don't want to lose 70% of our users as they're coming in. That's what keeps the system going. So internal validity we can deal with when we can run experiments. And we do this regularly. We put up different versions of our algorithms, different versions of our interfaces, not only on Movie Lens, but on systems like Cyclopath, on the other systems that we've built, and see what happens. External validity is the question of how well does the setup that you've created replicate the real world? Can you generalize from this experience? It's the question we are asked every time we try to do anything with Movie Lens is, does anybody actually care what people do on a movie recommender system? The answer is no. We don't even care. It's not that interesting. But we care to the extent that for the things that we're doing, a movie recommender system might help us have insight about how people would behave in a broader set of systems. And we're trying to address this in our most current research. We've been doing work on crowdsourcing. We've done it in Movie Lens. We're doing it in other systems too, where we're taking basically the same experiment and replicating it across different populations and different domains, with our fingers crossed that the results will be the same. Because if the results are the same, we have some hope in saying, maybe this thing is true as a general principle of people interacting with social systems, instead of this is true for people who are fans of Star Wars, which is not necessarily the direction that we want to go. One more thing, mostly something I want to direct towards the students here, which is about the importance of claims when you're talking about research. At the end of any study in research, somebody's going to ask you, well, what did you find out? And that's the wrong question. We know what you found out. You found out this was a lot harder than you thought it was going to be. And it took more time. And the users really are not as bright as you thought they would be. We all know that. The real question that you should be asking is, what can you claim as a result of your work? And this came up, and I'm going to give most of the credit in this to Bonnie John, formerly of Carnegie Mellon, now IBM. She had done a panel. Oh, that's right, she went to Cooper Union. Thank you. She went to Cooper Union, and now they're not tuition free. I don't think the two are associated, but I don't know. And if it relates to her getting paid well, she deserves it. She did a panel at CHI a number of years ago where one of the questions that was being asked is, does every paper that comes to CHI need a user study? And she answered it in the most intelligent way I've heard that question answered, which started with, no, of course not, but some do. How can you tell? What are they claiming? The evaluation in your paper depends on what you're claiming is the contribution that people should be able to take away and generalize from. If you build a system where I control this slideshow by using semaphores with my arms, and I want to claim that that system is easier to use than this remote, one, I'm an idiot, but two, I need a user study, probably. If what I want to claim is that that system is novel, I need a literature review. And I show that nobody has ever built one of these systems before. Then when I see that claim, people will probably throw away the paper because it's not interesting to say I can do something that's never been done. They want a claim that says it has value. If I want to claim that it's more accurate for something, I need a study that's going to measure accuracy, which may be a user study or it may be another kind of study. What you come back with is going to come back with what you claim, and I'm going to say that for a minute because we're moving to the next piece of this where this will come back. And so what I said was, at the beginning, I love experiments. That's what I like doing. I like building stuff and trying it out on people. That doesn't mean I run experiments all the time. I found a lovely silver bullet that was available for sale online, and I stripped the picture out of where it was being sold and put it into my presentation for one reason and one reason only. Why do you want a silver bullet?
Werewolves.
Well, that's one reason, to kill werewolves. Why does the Lone Ranger want silver bullets?
So you with that.
Well, one is it's a calling card. The other is as a reminder that they're valuable, that you don't go shooting randomly and just shooting all the time. Yeah, I traced this story back. I'm not a huge Lone Ranger fan, but it made a wonderful point. If you love experiments, you don't waste them. You don't waste your users. You don't offend people by having them do something that's ridiculously halfway. And that means that you need data first. You review your literature, you understand the theory that's going on. You may study usage data if you have a live system. You study your log data. You do all of those things. and figure out the questions that need those experiments. You never start by saying, well, why don't, I've got an interesting question. I mean, there are people who do this. Don't do this yourself. You know, if you say, I wonder whether, you know, people who get products on a blue background versus a red background are more likely to buy the product. It's a reasonable question. You don't start by building an e-commerce site and putting red and blue backgrounds out at random. You start by finding data from an e-commerce site and seeing if the purchase rates on the things that just happen to have had blue and red backgrounds were different. And then you might come back and say, but there's other things I couldn't control from that. You know, the things on the red backgrounds were displayed differently. There were other things. Now I want to run an experiment. You might need to do that, but you don't start there. And so, you know, there's just an amazing amount of stuff you can do if you understand where things are. And I want to give you a story related to this. We've often in our lab thought we were very clever. This has not always been a good thing. We, at one point, decided that it would be worth interviewing a bunch of our users to see if they thought we were as clever as we thought. No, not quite that, but to understand. We went very broad. We hired a psych student. Turns out nothing we had this person do required him to be a psych student, but he was looking for something to do, and we wanted to interview a bunch of users, and we figured, oh, he should be trained to do that. And we basically asked users why they used the site. We asked people how they thought it worked. We had, by the way, a beautiful intro screen that explains how it works. And then we got the stories of what users really thought. And some people are laughing now because they know the one I'm going to talk about, which is the user who thought that the way we came up with recommendations for this user was that we sat around the table and figured out what movies we thought she would like. You think about it, it's not just no more absurd. It's as plausible as saying, well, no, we actually have these large matrices. And the matrices magically do all of this. But you learn a lot by observing people. We did this again in another study. This was a study we did with an economist, wonderful collaborator, Yan Chen at the University of Michigan. And it was a study that showed us that everything we thought we were doing was based on a flawed assumption. And I'll tell you the flawed assumption because it's such an obvious assumption that none of us saw the flaws. And the assumption was that people use a movie recommender system to get recommendations for movies. It seems clear. And she wanted to build an experimental model that would show things like how much value the system was to people based on how many recommendations they got and other things like that in their usage. And the model wasn't working. And we did a survey to find out why people used MovieLens. And indeed, the number one reason people gave for using MovieLens overall was they like to get recommendation for movies. Very close behind number two was, I use MovieLens to rate movies. You're not shocked enough. I want you to understand how shocked we were. That would be like for us saying, if we asked people, why do you put money in parking meters? Well, number one, I put money in parking meters so I can park there and not get ticketed. And number two, it's fun to put the quarters in. Our model was based on the idea that rating is a cost and the consumption of the recommendations is a payoff. But the users thought the act of rating was a payoff. And it was no surprise that the model didn't converge because our costs were actually negative for many of the users. You get this stuff when you actually talk to people. Last part of this piece. How many people here have heard the term big data? Okay, what is it?
Doesn't fit into main memory on one machine.
We don't know what big data is. And I'll tell you, I do analytics. I like data. But there is a challenge. And this is the challenge I was talking about at the beginning, that there are a lot of papers that are very little more than saying, there was a data set, and here's what my algorithm says about it. Guess what? I found 173 statistically significant correlations. How many did you look at? I don't know, about 4,000 or 5,000? What's your p-value? 0.05? Oh, so you found the random ones. Now you can fix that with statistical corrections. You can stop pure data mining. But in fact, a lot of what has gone on in social computing has been, I've got a big data set. Look at this. And a lot of the great advances have come from other things. Now, I don't mean to say that data analysis is a bad thing. You can diagnose problems and find things with data analysis. So a wonderful example of it is the data that's out there on Wikipedia that shows, for instance, about the loss of new editors. New editors who are reverted tend to take their marbles and go home. Shocking. It's not enough all by itself, but when you see the numbers shown, you realize, turns out the follow-up paper on that was actually more fun. Some people didn't look at the follow-up paper, but the follow-up paper basically said, and you know what? We would be better off without most of those new editors. This was the paper that was under the title, Wikipedians are born, not made, that said, most of those people, if they don't do good work up front, they never turn into good contributors. Oh, that's sort of interesting. We need to think about this. You can sometimes understand context, prevalence, details. So some work that was done by folks in our group looked at the specifics of interactions in online gaming and looked at how people engage in abusive behavior towards each other in online multiplayer games. Not sufficient work, but it did show a few interesting patterns. One of the ones that I still think is sort of interesting is that there's a set of people who mostly are abusive in their last game in a series of games. That gives you something to follow up on. Doesn't actually tell you what's happening, but it gives you something to follow up on. Frequently, analysis is great in trying to go and develop a solution before you try it out. So analysis has a lot of places to go, but you've got to figure out where your questions are coming from. I'm going to skip ahead because I want to move towards a little bit of discussion. And the last couple of things I wanted to take us through is this question of infrastructure. So I've told you a little bit about our group. I'm now going to tell you a lot more about our group. We like our group. So this Group Lens group was, founded in the original sense about 20 years ago. John Riedel worked with Paul Resnick at MIT to do the original Group Lens system that was published in 94. In 95, I joined them to create a large-scale experimental deployment that got us, in our view, large-scale, 200 users. 200 was big. And frankly, 200 was big at the time compared to the other things that people were doing. And other than doing commercial spin-offs and continuing to do work in recommender systems, the major milestones were, I'm going to attribute to people and systems. Movie Lens, which I told you about in 1997. We didn't build another recommender system for a long time. We brought in Lauren Terveen, who joined us in 2002. Lauren then built the Cyclopath system. We started in roughly that same time a whole bunch of research, including tools and experiments on Wikipedia, where we have plugins and all sorts of things that allow us to study Wikipedia work. We've started building some additional recommender systems and systems infrastructure there. We now have a system deployed in public libraries. We have toolkits that are out there. We have data sets. We've brought in 2 new faculty in the last year and a half, Brent Hecht and Lani Yarosh, who are bringing their own systems. Brent has done work looking at intercultural data as expressed in Wikipedia, as well as other things, and has systems for visualizing, displaying, and processing the knowledge across different languages. Lana has done experimental work, including systems that do remote communication for separated families, looking at things like how children who are of divorced parents or children with deployed military parents can interact and keep up to date. We're adding one more person who's coming this fall, Haiju, and we're probably not going to be allowed to add anybody else for another year or two. But we pride ourselves on infrastructure. We staff for infrastructure. We have one person who's a full-time research scientist who keeps things running. And the best thing about infrastructure is that we can control things. Movie Lens is still the heart of a lot of what we do, and it is the heart because we can count on reliably new users coming in at the rate of about 150 a week, and old users coming back at 600 to 700 a week. You know, we talk about we've had over 100,000 users. They don't all show up this week. But that allows you to run some really interesting experiments. Actually, there's some people in this room who made some of that possible in the code, where we can track a person and assign them to a random category and say, you're going to get a different experience not only today, but for the next 6 months. And we can measure whether you stay around, how much you contribute, how much you come back, whether your ratings are more positive or more negative. We can't tell whether we don't have a social network. We can't tell if you're happy yet. But we can do a lot of stuff with people because we run a system. There are some downsides to what we do. It's expensive. Anybody who thinks keeping a community running is cheap, it's not. It has some wonderful investment returns for students who build stuff. Building things is really rewarding, but it takes time. And frankly, it makes things harder to generalize. We're getting there. With enough faculty and enough students, we can do experiments across projects, but we couldn't for the first 15 years of that platform. And that's something that's a challenge. There is an alternative. People experiment out. You know, it's cheaper. You can use somebody else's existing community. There's just a few big problems here. One is frequently you can't get to the systems you really want to run the experiments in. I mean, I see commercial systems I would love to play around with, and somehow Google and Amazon and other people don't want me messing with their customers. They're wrong. I would be nice, but you have to respect them for having the right to make that decision. They put constraints on some of the ones where you can experiment that often stop you from doing the experiments we want to do. Our best way of experimenting is actually sending students as interns, because sometimes as an intern you can run an experiment, but often the experiment you can run isn't the experiment you want to run. It's the experiment they want to run, which is not always as interesting. But cooperation, consent, those are all challenges. And you still get these issues of generalizability and even face validity when you put things into a system that you can't control things of, because there are issues there. And running a system is not the same as running experiments. I mentioned this briefly, but the idea of having the logs, having the A/B testing, being able to track students, just expect that adds another 100% to your development effort. If you want to put up a system that just works and you want that system to be able to support this, it's getting better. There are some decent frameworks now where you can make it add only 40% in some cases. Depends how much of it is all web, but it's extra effort to get there. Last of these things to think about as you're thinking about research. Lab and field. We talked about experiments. Experiments is a nice word, but it doesn't actually say what you're talking about. So we fundamentally run two types of experiments in our group. We run online lab experiments where we recruit people typically from among our users, but not always. Sometimes we recruit them on Turk and other places. We put them into some special environment. We have them do something. We measure the result. Why do we do online lab experiments? They're easy. You get really nice internal validity. You control everything you possibly can, and you randomize anything you can't control. And you have one factor that you can study. We also do online field experiments where you give people different experimental conditions and you run them for a while. And when you're dealing with online field experiments, we lose a lot of that internal validity. People have different rates of attrition in the different conditions. You have to deal with that. People have other things that change their behaviors. But what you get is greater external validity. It reflects what they really do in a real circumstance and not simply what they do when you tell them you have 20 minutes, fill out this form. There's benefits to all of those things. The one we're doing right now that to me is the most fun is we did a survey to ask people about algorithmic preferences and assign them different algorithms in our system. And now they have a system where they can go change the algorithm as they want. And we're already seeing results coming back saying that certain algorithms, when people try them, they stay. And certain ones, people leave. And ironically, some of the ones that people leave are the ones that the published literature says are the best. And the published literature is wrong, at least for our circumstance. It is the best in numerical measures. It's not the best in user experience, and that's the kind of thing that we want to find out. So about those concluding thoughts, just going to say a couple of them. One, platforms are hard and expensive. We need to figure out how to share them, and we need to figure out how to fund sharing them. Not going to say more about that. Number two, I know a bunch of you are actually doing this kind of research. Those people who are more senior need to continue to push to get this stuff rewarded. It is way too easy for somebody to look better than you because they had 7 papers last year, each of which analyzed a different slice of a data set, and all you did was build a system. The National Research Council actually had a report that was instrumental in my career, came out, I think it was 92, talking about experimental computer scientists and engineers and what had to be done to support those people. The number one thing it talked about was they're not going to publish as much. You've got to measure the artifacts that they create and the impact of the individual publications, not just the count. There's probably something needed to keep reminding people of this. Experiments are hard, that's nothing new. If there's a final message I want to give you, what we've learned from more than 20 years of doing this stuff, think about your impact. What's the question you're answering? Does what you're interested in need experimental evidence? If you need these things, think about teams. How do you put together the people that do this? And think about the investment it's going to take to go after the big questions, because those are the questions we all care about. I'm going to thank lots of people all at once and invite you to continue this with your discussion.
We have time for maybe a couple questions. If you need to go at 2:05 to make it to another class or something, we understand.
If you don't need to go and just want to, I won't feel bad either. Questions, reactions?
I just had a thought about talking about Wikipedia.
it just seems that since, if you go back a few years when everyone was sitting at desktop computers, people were probably more productive than now with mobile devices. So I was just wondering whether that's something that you factor into the general change in behavior.
So let me answer your question twice. I am not aware of a study that looks at quality differences or productivity differences of based on whether somebody is mobile or not. I'm sure somebody's looking at that, but I'm not familiar with the results. And if anybody's looking at, the most likely people are actually inside the Wikimedia Foundation, because they're the closest to the data that might help determine it. It's not always easy to tell. It sometimes comes through in the browser ID. If you can't get it from the browser ID, it's hard to know reliably whether somebody's mobile or not. The question of whether people are more productive, though, I think is much more complicated than that. I think there are ways in which people are less focused, but more able to be productive immediately in a mobile computing setting. And we see this, that people get answers to things that they used to have to remind themselves to do later, which is a sign of productivity if you take a task and dismiss it rather than delay it. So I'm not sure I would buy the premise that people are necessarily less productive because they're walking around with things like this. But it is certainly true that you can do the objective measures of things like text input speeds, and we haven't reached the point where the population on average can input as quickly on some of those devices as on a keyboard. Sometimes that's not the best measure of productivity, though. Yeah.
So I loved your discussion of, when you run an experiment, what are you trying to get? What contributions are you trying to make? There's often this divide between what I can measure people doing, like input speeds, and what I actually want to show, like something towards this will save the world, or people really love this, or something more abstract, like in a lot of UX stuff. So I do crowdsourcing work, and one thing, if people don't like the task, they won't do it. I can't measure that. I can't say, well, I put this on Turk and nobody did it, and therefore I had to make it better. Like, I have to bring it up to a level where it's enjoyable enough to compete with everything else. And but those things are really hard to measure, but they're the most important.
They're not always hard to measure. They can be. I mean, you can actually do experiments to measure things like appeal of tasks, if that's the question you want to get to. The problem I think you're raising is that's not what you're studying. That's just what you need to get through to get to what you're studying. And this is part of the challenge of the work that we're doing in this field is, and this is why I say that approach of start with claims is so valuable. If you go back and say, well, what is it that you want to do? You're not going to get directly to the conclusion, I saved the world. But unless you're going to make a claim that saving time is important in something, showing that it's faster may not have a lot of value. You do need to find something that you can measure that you can also make a connection to why it's important, and that's often the role of theory. And it's also often the role of models, that you can come back and show, okay, we have a model. We have theory from economics that shows that productivity leads to income. It's not perfect, but we understand the notion that if we can make workers more productive, then in a free market, they can command a greater income because one of the factors that determines their income is the amount that they produce for their employer in whatever form it is. If you start with that, you now have an a priori theoretical justification for saying, if we can make this faster, we can help people. It may be enough to show that you can make it faster. It may be that you need something that's a bigger chain than that. But taking the theoretical results that are out there in the prior work lets you set your work in a context where the thing you can show, you can connect the dots. Eventually, for many of those things, somebody has to show that what you've done is not just prove the exception that, well, people make more if they work faster except in your domain, But that's not where you have to worry about first. Start by making the connection to the things that people have already shown.
Yeah.
Huh?
May I? Okay, so I'd like to actually give you another soapbox, just because I'd like to hear your thoughts. Oh, sweet. Just because I'd like to hear your thoughts on this. So you talked a lot about. Okay. Oh, now it's off the record. Excellent. You talked a lot about infrastructure, and you talked a lot about experiments. When I'm thinking about research contributions or talking with students, there's also sort of the role of what you might call systems, which is maybe more of the. I might put it this way: engineering might be about being able to transform a problem statement into an approach that is likely to work, like build a bridge that works. The art, what you call art in many ways, I feel like is about, the contributions feel like I'm giving you a new color, a new kind of paintbrush, something that allows you to do something that you weren't able to do before. And I felt like that was a little bit less represented in your presentation. So I wonder what your take is on when we should be entering each mode of research.
So I think that's really important research. It's not what I mostly do, which is why I didn't talk that much about it. I value the people who do it. But I think it's critically important to come up with environments where somebody, and it's not always the person who has the technical ability to make the new paintbrush, somebody figures out what that new paintbrush is good for. And we have this interesting challenge. I mean, I spent a fair bit of time in the WIST community, the User Interface Software and Technology community. And in its early days, we had a lot of papers, including some by me, that were basically, hey, look, I can do this. And I think the community needed that. It needed somebody to show all the things you could do so that other people could put those components together into something somebody would want to do. My contribution was, we can build a toolkit that's based on the principles of programming languages. In the end, the paper was well received, and nobody ever did anything with that again. Because none of us knew why you would want to do that. It was just intellectually fun to try. And it's okay to do some of that. But I think that the stuff that's really impressive to me, and this comes up probably biggest of all in areas where people are talking about creativity support, is to create environments where you say, well, when I put this in there, I'm actually finding that people are being more creative, or being creative more effectively, or with less frustration, or are able to manage larger teams, or are able to get by with smaller teams, or whatever the right measure is. And the challenge with that kind of work, and I mean, I've talked to a number of people who do some of it, is it's painstaking to get people to adopt a new technology. You can't do it the first time through, but you can start with the idea that at least I know what this is supposed to be good for. I tie it to some of the theoretical things, and then I think that work is just incredibly important for our field. I mean, to me, it's not fundamentally different for us than the people who are doing quantum computing these days. Because, the first question of, well, can you make a computer that uses this stuff is sort of interesting, but it's not worth that much investment until those folks came back and said, you know what, we have a whole group of people who are working on not how do you build a quantum computer, but if it existed, what problems can you solve with it? And a different set of people that are working on how do you make it work, and some who overlap. And with those two groups of people working together, that may turn into something really important. If the second group didn't come around to figure out what to do with it, people would look, they'd say, cool, qubit, what's next? And unfortunately, I think that happened with a lot of the early pointing technologies, where people showed every possible way to point. It just overwhelmed people with, yeah, there's lots of ways to point. What's wrong with the one I have right now? And I guess the answer in very pithy terms is, yes, if you build a better mouse, people will come to your door, or whatever the question.